So G sub C is X. So let's say we're going to do G9. Oh no, let's make a smaller, G3. Okay? Because so I finished my proof. So let's do G3 of X. So let's put it orange no. Let's put it red. So that means I'm gonna divide in 3 parts. So 1, 2, 3 parts. What is the smallest between here and here? Will be this one. Let me use a big fat one. So that will be first. What is the inf between here and here? So I'll look the inf between here and here. So my inf is gonna be this one, and my inf between this point and this point is gonna be this one. So the red one is G3. You see, G3 is less than G6 because at this point is 0, but at this point is this point. At this point you have this value, but at this point is at G6 is bigger. So it's a matter you draw it and try it. Yeah. So there's the smaller intervals you get more division, so the function is higher. So now let me define the other one, and then we finish with the proof. So but before that, so we had these functions. We had the limit exists. So functions grn of x are integrable for being step functions, right? Those are step functions or simple functions. Well, actually we're doing so step functions, and thus by Lebesgue dominated convergence theorem I can do integral g d lambda equals the limit of the g on n goes to infinity. Okay, and actually because they are simple functions, well let's leave it like that, g n d lambda. That's by Lebesgue measures. Okay, because they are simple functions, I can do this. Okay, so now similarly I define the upper one. Similarly, we define h sub n of x, but instead of taking the inf, I take the sup. I will take the sup of the f of x such that x is in the interval and so on, and 0 otherwise. So of course, because I take in the sup, now instead of the inf, I have h of n of x is bigger or equal to g sub n of x. Okay. Also for the same construction, h of x equals the limit exists and also I can do the Lebesgue dominated convergence theorem. Integral of h d lambda equals limit integral of the limit the limit is apart h n d lambda n goes to infinity. Okay, so finally since f is Riemann integral, So we have integral of g d lambda equals limit of n goes to infinity of integral of gn d lambda. So I haven't done nothing new, but I have step functions. So these step functions will agree as Riemann integrals because they are step functions. Simple functions and step functions, they will have the same integral by definition. Okay, because it's the Lebesgue integral, not any integral, it's the Lebesgue. So we will make sure that those were good. But then, you know, when you take the areas becoming really small, the sub and the inf is gonna agree. That's for Riemann integration. So that one might require some argument, okay? But it's because Riemann is not that easy. But if you draw it, you believe it. So when you have Riemann integral, you take the upper sum or the lower sum, the limit is gonna be the same. But that requires some proof for Riemann integral, but we don't have time to do it. But then this is gonna be the same that because there are step functions, they agree. The Lebesgue and the Riemann integral agree, and then this is let me erase here. This is the limit. Well, sorry, change my erasers. Seems like it's not working now. So let me eraser. Okay, so this is the integral of this is the I don't know what I did now. Yes, this is the integral of h d lambda. So in conclusion, we have h d lambda and this h d lambda and g d lambda are the same, right? But also we have that g is less or equal than f and less or equal than h. Okay, so since g, so remember, by the proof, who proved this? So Sankei proved this, right? That the integral, if the two integrals are the same, then g and h are equal almost everywhere, right? Remember you proved that? So from that conclusion, from Sankei's work, g and h are equals almost everywhere. So g is less or equal than g, f is between g and h, g is equal to h almost everywhere. So h equals f almost everywhere. So this proof f is Lebesgue integrable. And then to finish, the two integrals are the same because the integral between a and b of f of x dx equals the limit of n goes to infinity of integral of ab gn dx, and this is equal limit of n goes to infinity of integral of ab Gn d lambda, and this is equals to the integral of AB g d lambda, and this is well, I should say h, because I said h of n, h of n, h of n, h is equal to the integral of AB f d lambda. So sorry, so because I can use g on n of h of n, but since I use h equals f, so I had to stay with h, because I said, but I could use h or g. It does give you the same, because they are the same almost everywhere. So conclusion, my Riemann integral is equals to my Lebesgue integral. And and then, so with that we conclude the course, the class. Okay.